What is the probability that at least two persons out of a group of three, so, were born in the same month? Okay. Getting birth in same month, two persons, at least two is asked. Okay. Same month. Probability of getting birth, same month, at least two people. I've read it here. So event reads like probability of at least two people getting born in same month. Okay. So whenever we discuss about at least situation, so we imagine the number line of event that no one 0% taking birth in same month, okay, or one person taking birth in same month. They are all they are the same events, because one person can, if one person is taking birth in a particular month and only one is taking birth in that particular month, so the event is still not happening. When there can be only at least two persons to take birth in same month, or three persons. Okay, 1 and 0 are just not happening. Now, these events are cannot be called as that getting birth in same month. Now, this cannot happen with 0% and 1%. So here what we have to find out, at least two or more than two. So at most we have three. So what we'll do, we'll find out the probability of event minus 1 minus probability of no one uh, getting the birth in same month. No one getting born in same month. Now, what is the probability of event E? Like what is the event E here? Event E is probability of at least two people getting birth, because at least one case do not exist here as we are comparing two values. So probability of at least two people getting birth in the same month will be 1 minus probability of no one getting birth in the same month. Is that clear that how have I written the formula?
Yes, sir.
Yeah, please remember the concept that we have talked earlier. Exactly 0, exactly 1. Now this is out of question. This is just a concept. Exactly 2. And for at least 1, we will consider all the values to rightwards. And for finding at least 1, will minus total with exactly 0. So this is exactly what we are doing here also. So continuing, this will become 1 minus probability of getting no person getting born in a particular same month. So let's say if there are three persons and any month cannot be repeated. So one person has like one person can get born in 12 months, but the other person should not get born in the same month that the P1 has got birth in. So P2 will have 11 choices. P3 will have 10 choices. Is that clear? Is that clear? Yes or no?
Yes, sir.
Yeah. So the probability here in this case, first of all, favorable number of outcomes are 12, 11 into 10. What if there are no conditions? So so here, if there are no conditions, then the person first, there are 12 choices. For person second also 12 choices, because there are no conditions. they can get born in any month. So 12, 12 into 12. These are the total number of years. These are the number of favorable outcomes. 12 cancels 12. 10 by 2, 5. 12 by 2, 6. 1 minus 55 by 72. 72. 72 minus 55. Now let's solve. 55 uh, plus 15 becomes 70 plus 2. So 17 will be the answer. 17 by 72. Any doubts?
No, sir.
Okay. So let's check. See, same. Probability that no one get born in the same month. First person have 12 choices. The other person will have one choice subtracted that P1 has born in. Two choices are subtracted. Then a total 10 choices and total number of outcomes. There is no mention of any condition here. So just total number of choices. So probability of at least two persons getting born will be 1 minus probability of no person getting born in the same. Okay. Now, can you tell me what is triangle inequality? What is the condition for three sides to make a triangle? That they have to follow that particular condition. The condition is the sum of two sides of any two sides of a triangle should always be greater or equal than the third. No, not equal. Then the third side. When I refer to side, I am referring to the length of the side. Okay, so this is the condition for making any triangle. And this condition is known as triangle inequality. If there are three sides, then A plus B should be greater than C. Okay, and AB, like just for the ease of our convenience, we can also write it as that B plus C should be greater than A and C plus A should be greater than B. But mostly to check, we take two shorter sides. Sum, which should be greater than the largest side. Just to check, we consider this scenario. Otherwise, the original equation, the original inequality is this. Is that clear?
Yes, sir.
Yes, great. Okay, so here, let's read the question then. The question says, there are 5 sticks of length 1, 3, 5, 7, and 9 feet are given. 3 of these sticks are selected at random. So there are 5 sticks, 3 sticks are selected. What is the probability that the selected sticks form a triangle? Okay, so for making a triangle, they has to follow certain order. Now let's take the shortest sides. 1 plus 3. Is this greater than the longest side that we have the option 9? No, it's not. So 139 cannot, the sticks of length 139 will not be able to form a triangle. Let's take another example. Is this 1 plus 3 greater than 7? No. So this will also not be able to form any triangle. 1 plus 3 is greater than 5? No, 4 is not greater than 5. So 1 is excluded in every triplet. Okay. So let's take, so 1 is excluded. Now we are talking about our favorable outcome. like favorable sticks that we can take. Favorable. Okay, one is just excluded. It's out of question now. 3 plus 5 greater than 9? No, 8 is not greater than 9. So 359 can also not be a triplet. Let's discuss about 3 plus 5. Is it greater than 7? Yes or no?
Yes, sir.
Yes. Okay, so 357 is a triplet that we can consider. Okay. What about 5, 7, and 9? 5 plus 7 is greater than 9. Yes, for sure. And there is no other examples left. We are going from left to right. Okay. So how many desirable case do we have here? Are we missing on something? 3 plus 5, 8. Haha. 3 plus 5 is greater than 7. Okay. We have taken this example. And what else we can consider? 5 plus 9, 14. No, it's not greater than anything else. 3 plus 7, no. 5 plus 3, no. Yes, no. 8 is not greater than 9. So 1 plus 9 is greater than 7, but 1 and 9 are not the shortest. 1 plus 7, 1 plus 5. Okay, 3 plus 5, 8, 7, no. 3 plus 5, 8, 9, no. 3 plus 7. Ha, we missed one case of 3. 3 plus 7 is 10, which is greater than 9. So this can be also a triplet. 3 plus 7 and 3 plus 9. So there is nothing greater than 9. So we'll not consider it. So 3 plus 5, 3 plus 7. Okay, done. And 5 plus 7 and nothing greater than a 9. So 5 and plus 9 cannot be taken as a shortest side. So how many possibilities, favorable outcomes we have? 1, 2, and 3. 3 favorable outcomes. How many total outcomes are there? So we have 5 sticks, and out of 5 sticks, we have to select 3 sticks. So these are the total number of ways in which we can select 3 sticks. And that is the probability of our event. Now 3 divided by 5 factorial. 5 minus 3 factorial into 3 factorial. 3 factorial cancels 5 factorial by 5 into 4. 2 factorial cancels 4 by 2. That becomes 3 by 10, which is 0.3. Clear? Or should I explain it again?
Oh,
Clear?
yes, sir.
Yeah. So we have to select 3 such sticks whose shorter sticks should be, if the sum should be greater than the longest stick. This is the triangle inequality. Yes. Here we can see their method is a little out of track, unexplained. Consider the following statements, and we have to tell which statements are correct. Okay, these are the options. This is a question of 2008. First statement. Let's verify the first statement. Probability of event A bar union with B set is equals to probability of A bar plus probability of B minus of probability of A bar intersection with B. This is definitely correct. Why? If we write A bar as C and B as D, then we'll be able to understand that how it is written. So C union D, as per the given statement, C probability of B is D minus probability of C intersection D. Now this is a formula, right? So if the formula is written here in some different format, then it is definitely correct. Clear?
Yes, sir.
That this is just a formula. Next statement, probability of A intersection B bar is equals to P of B minus P A intersection B. Okay, so let's draw its Venn diagram to understand. Okay, uh, A A set is this. Now we are talking about the A set's intersection with B bar. Okay, we have to also make the universal set for considering any complements. Okay, so B bar is what? B bar means excluding B set, everything is included. And its intersection with A. Its intersection with A is this only. The part that is there inside the A. Okay. So that is our LHS. Is that clear that how we have find it out A intersection B bar?
Yeah, sir.
Let's discuss about RHS then. B, complete B, and then what is subtracted from B is the intersecting part. This is subtracted. Okay. So are they equal? Is the shaded part equal? No, right? So
No,
this is
sir.
an incorrect statement. This is an incorrect statement. Okay. Now let's talk about the third statement. Probability of this is we have discussed in dependent events. And even if you just want to solve it, then also we can solve probability of B into conditional probability. Given that B has happened, and we have to talk about the probability of A. In this, the formula is A union A intersection B divided by probability of B. Probability of B cancels B. What is left is LHS only. So LHS is equals to RHS. Statement 3 is correct. Option B is correct. Any doubts?
No, clear, sir.
Clear?
Yes, sir.
Okay, great. B is the correct answer. Yes. So here also B is the correct answer. If event A and B are two events such that 2 into probability of A and it's given equal to 3 into probability of event B, where 0 like the probability of A is less than probability of B, and they are both unsure events, and even not like they have some probability in between 0 and 1. Okay, cool. So now in the options, we are looking at the probability of their conditionals. Like if A has happened, then what is the probability of B? If B has happened, what is the probability of A? What is the probability of both of the events happening simultaneously? We have to discuss the inequality between all of these. So we are very sure of one thing that probability of both of events happening will be comparatively low than any single event. That is for sure. Like when we draw Venn diagrams A union B is very comparatively less than probability of A or probability of B. Yes? Okay, nice. So that is one understanding that we are sure about, that probability of A union B, A intersection will be definitely less than A and will also be less than B. Now, if that is the case, then option A is ruled out, option C is ruled out. Now let's discuss about the remaining options, B and D. Here, we can see there is a contradiction in discussion of probability of one event when other one has happened. Okay, so for that we have to take a look on the given condition. So in the given condition, probability of A, it is given like this: probability of event A is less than probability of B. So for making, as we have to discuss the inequality between conditionals, so let's try to make the formula. Let's divide both sides by A intersection B. Now we know what is the formula of A uh, A event when B has taken place, probability of A intersection B divided by probability of B, which is precisely the formula just inverted. So this is what probability of event B when A, sorry, probability of event A when B has happened. Probability of event B when A has happened. Now we know. Sorry, and that too of inversion. Okay, 1 by. Now we'll cross multiply. We will cross multiply. Let me write it properly. This is the formula of what? This is the formula of probability of event B when A has happened. And that too inversely. Less than probability of event, inverse formula of probability of event A when B has happened. Okay, so when we'll cross multiply, when we will cross multiply, this will come in the numerator part. Probability of event A when B has happened will be less than probability of event B when A has happened. Okay. So if that is the case, we need to understand one more thing here. That is the given condition which is given to us. So probability of A is equals to 3 by 2 probability of B. I think there is a misprint in the question for sure. As per the given condition, as you can see here, as per the given condition, probability of event B is less than probability of event A, whereas it is given that probability of event B is greater than A. Let me redo it. I'm very sure there is a misprint. I'm very sure. Why? Let me prove it to you. See, see, we have to understand one thing here, that as per the given condition that the 2 into probability of event A is 3 times the probability of event B. So it is saying that probability of event A is 3 by 2 times the probability of event B. So from here we can directly conclude that probability of event B is definitely greater than probability of event A. Yes, isn't it? Why? Let me write it in ratio format also. Is equals to 3 by 2. Where we can see is equals to 3 by 2. Where we can see probability of event A has to be greater than. Then only it can become a value 3 by 2, which is 1.5. So probability of event A as per this has to be greater than. So this is the conclusion from given condition. But it is contradicting with the other given information. So that's why it makes the question contradictory. Let me check on Google whether this is a misprint in the book or in the UPSC paper only. Let me screen share my whole of window. Two PA is equals to 3 PP. 2 PA is equals to 3 PP. So the question is given correctly in the book. Okay. And our answer is this here. Okay. 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 ठीक Still I'm not convinced. तो यहाँ पे क्या हो रहा है कि this is given condition, okay, and this is another given condition. So what they are doing is that they are dividing it by probability of A intersection B. ठीक है. So after that they have solved and expand. They have solved it, and further they have written that this is the formula of conditional probability of event B when A has taken place. Okay, fine enough. And this is the formula of event A when B has taken place. Okay. So from this, they conclude that the probability of event B given A has taken place is less than the probability of event A given B has happened. Okay. Why they are writing so? Because the ratio is 2 by 3. So it means that probability of event A will be greater. Okay, I agree. If that is so, let us check whether we have done any mistake here or no. So in this case, probability of event A should be greater, then only it can become more than. Okay, nice. Now from here, they have said that probability of event A is less than 1. So, 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 okay, okay. Given PB is less than 1. No, I am very sure that this question is incorrect. This question is incorrect. I repeat, this question is incorrect. Let me re-screen share my slide. I'll discuss this question with one of my friends. We'll get back to if there are some changes. For now, this question stands misprint and a misinterpreted question as per my opinion. If my opinion changes after the enlightenment of my friends, then I'll definitely make sure to mention it in the next class. Okay. Okay, shall we move ahead to next question? Because in this question, the given conditions are only contradicting. How we will be able to find out the solution? I may be incorrect also, but that is very much truth as per my current understanding. Let's go ahead. Let's finish the chapter today. A box has 10 chits from 0, 1, 2, 3, 4. So a box has 10 chits from 0, 1, 2, 3 to 9. Okay. First one chit is drawn at random. Okay. Then kept aside. Okay. And then from the remaining, a second chit is drawn at random. And was the probability that the second chit is drawn is 9. Okay. So how many chits can be withdrawn at first? There are 10 cases. We are discussing about, we are not discussing about the favorables. We are discussing about just how many cases are there. But, and how many chances are there for the withdrawal of the second ticket? There are 9 chances. Because one is already withdrawn. Okay. For our favorable outcome, how many cases are there? How many choices do we have to withdraw the first ticket as? That is only 9. Because we cannot withdraw the ninth, because as it is required in the to be drawn in the at the second event. So we have only 9 choices. How about the second one? Only one choice. Okay. So these are the favorable. 9 into 1, 9 favorable ways. Total ways 90. 9 by 90 will be your probability. That is 1 by 10. Option A. Option A is the correct answer. Is that clear?
Yes, sir.
Option A will be the correct answer. The next question is if the probability of simultaneous occurrence of two events A and B is P. Okay. Probability of simultaneous occurrence of two events is P. The probability that exactly one of A or B occurs, exactly one of A or B occurs. It would be better if I write like this only, exactly A or exactly B occurs. Then which one of the following is or are correct? So this is clear that when both of them are occurring simultaneously, so this is the intersection B. A is this, B is this. Exactly occurrence means that this part is involved or this part is involved. Nothing in common. So probability of A plus probability of B minus excluding the common part twice. Or should I say, it would be better for me to write and explain it like that, that this part is A minus A in union B, A intersection B. Okay, probability of event A, probability of A intersection B. This part is probability of B minus probability of A intersection B. And we add them both. Then it comes out as probability of A plus probability of B minus of twice of probability of A intersection B. Okay. So this is given as equal to Q. Is that clear, everyone? Yeah, Yarini, is that clear?
Yes, sir.
Okay, so let's better represent the facts. Now, the first statement says the probability of event A bar plus probability of event B bar is equals to this. So, probability of event A bar can be written as 1 minus probability of event A plus 1 minus probability of event B. Okay. So, it makes it 2 minus probability of A minus common then probability of event A and probability of event B. Okay. So this has to be equal to the 2 minus 2p. That's the RHS. We'll talk about it later. So first, let's now discuss the how we can find out probability of A plus B. That will be 2 plus. Now this is what? P A intersection B. This is P, right? Probability of A intersection B is P. So Q is equals to P probability of A plus probability of B minus of 2P. So probability of A plus B becomes Q plus 2P. Is that clear? From here we can write Q plus 2P is equals to probability of A plus probability of B. So similarly, we can write here also 2 minus Q minus 2P. That is precisely the first statement. So our first statement stands true in the test of truth. Yes? Is that clear?
Yes, sir.
Okay. So the second statement is probability of A bar. So from here we can recall the Morgan's law. This is equal to probability of A union B bar. Yes. So this can be written as 1 minus. Let me save the file first. This using the Morgan's law, we can write probability of A bar intersecting with B bar as probability of A union bar whole bar. A union bar whole bar. Sorry, A union B whole bar. That's the De Morgan's law. We can equate it to A union B whole bar, which can be written as 1 minus probability of A union B. 1 minus, what is A union B? Probability of A plus probability of B, which is uh, probability of A plus, where is probability of A in? Here it is. Q plus 2P minus probability of A intersection B, that is P. So that is basically 1 minus Q, 1 minus P, which is makes our second statement as true. Is that clear?
Yes, sir.
Okay. So let's now solve some questions are left. Let's solve them quickly. Whose class is next?
Science. Yes, sir.
They have taken our time one day. We can take theirs also today. Next. We have studied about this question earlier in our class about occurrence of two events at least. Occurrence of two events at a same point of time. So A intersection. So we'll consider this much area only. So we'll sum the all of the intersection thrice, but we know that this is getting calculated thrice, but we want it to get calculated only once. So we have subtracted it by 2. And we have also discussed in our earlier class. If there is any doubt, we can discuss it once again. Is there any doubts?
No, sir.
No. Okay. So that was the last question. Okay. This is like A event, B event, C event. we have to talk about the occurrence of two events simultaneously. So it's like discussing about this and this and this. But the problem will be that if we add them all, then this part will get calculated thrice. But we only wanted to get calculated once. So that's why we are subtracting it twice. Clear?
Yes, sir.
Great. Thank you, everyone. Jai Hind.